Hello everyone, this is Adnan. Welcome to Chemistry with Adnan. On this channel, I'm covering the entire IGCSE Cambridge Chemistry syllabus. The course code is 0620. I'm also covering the other exam boards such as AQA, EdXL, OCR. So if you are registered with the AQA, EdXL or OCR, so you can find your relevant playlist. So in this lesson, we will be covering 2.5, which is simple molecules and covalent bonding, right? So simple molecules and covalent bonds. Okay, so the first two topics I will explain together, like I will merge them because they are connected. So state that a covalent bond is formed when a pair of electrons is shared between two atoms, leading to a noble gas electronic configuration. So this topic requires you to memorize the definition of a covalent bonding, of a covalent bond, in which two keywords are important. The first one is pair of electrons, that a covalent bond is formed when a pair of electrons, so a uh, pair of electrons is shared between two atoms. So between two atoms, right? And these atoms are non-metals. So covalent bonds, they are formed between non-metals. Two non-metals are involved, and they share electrons, a pair of electrons, to make a covalent bond. So the next topic is describe the formation of covalent bonds in simple molecules, including hydrogen H2, Cl2, a chlorine molecule, chlorine gas, water H2O, ammonia, this is methane CH4, ammonia NH3, and HCl, hydrochloric acid. And use dot and cross diagrams to show the electronic configurations in these and similar molecules. So now, how do we draw dot and cross diagrams? This is a topic which confuses most students. So let's take a look at how do we draw these dot and cross diagrams. So step one, you let's say we are drawing the dot and cross diagram for hydrogen molecule H2. So let us look at its electron structure. It is just one, right? Because in hydrogen we have only one shell that contains just one electron, right? And we have another hydrogen atom that will also have one electron. But remember that the electron of the other element or the other atom will be mentioned as a cross, so that they can be distinguished when these electrons are shared. So we can see that how each atom is contributing to the shared pair of electrons, right? So now this is the first step when you draw these. And now you should ask yourself that how many electrons are needed to have a complete outer shell. So now we can see that since this is the first shell, hydrogen only has like one shell, which is the first shell, and or the outermost shell at the same time. So the first shell can accommodate a maximum of two electrons, right? So one is already there, and it will require one more. So similarly, the other hydrogen atom, it has one, and it needs one more to have a complete shell of two electrons. So what they will do, they will share, both of them, they will share one electron each with each other, and a bond will be formed. So how do you draw this on your answer sheet, in the exam? So you draw one hydrogen atom, then you draw another hydrogen atom. Their orbits, they must overlap. And now, since each hydrogen they have one electron. So these electrons will be shared like this, right? Yeah. So now you can see that this shared pair of electrons can be counted for both these atoms, right? Now we can say that this, let's call this hydrogen A, and let us call this hydrogen B, and we can say that hydrogen A has two electrons now, and hydrogen B, it has also two electrons, and it also has a complete duplet, or a complete outer shell with two electrons. So this is how basically you draw a dot and cross diagram. So let us practice more. Now let us apply this on chlorine. You can pause this lecture here, and you can try by yourself and see that how you can draw the dot and cross diagram for chlorine molecule. So again, step one, you draw the chlorine atom. So chlorine, if you look at the periodic table, you will find chlorine in group 7, and it is in period 3, right? So group 7 means that it will have 7 electrons in the outer shell, and period 3 means that it will have 3 shells, right? So and its atomic number of chlorine is 17, which means that it contains 17 electrons. So the electronic structure will be 2, 8, 7, right? So 3 shells, 2 electrons in the first, 8 in the second, and 7 in the third. So now let me draw the structure. So chlorine, 2 electrons in the first shell, and now 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons in the second, and uh, 7 electrons in the third. So 1, 2, 3, 4, 5, 6, and 7. So this is the first step. This is how you draw the two atoms that will make a bond. And so this is a first shell with 2 electrons. This is second shell with 8 electrons. Oh, I must draw these using a different symbol of like cross. So 1, 2, and uh, now I have to fill the second one with 8 electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. Now the third shell, the outer shell, will have 7 electrons. 1, 2, 3, 4, 5, 6, and 7. Okay, so now in the second step, you should again ask yourself that how many electrons are needed for each chlorine atoms to have a complete outer shell. So 7 electrons are already there, and in the third shell, the maximum number of electrons that can be accommodated is 8. So each chlorine atom will need one electron, right? So in total, 2 electrons will be shared, just like hydrogen molecule. So each chlorine atom, so this chlorine atom, it will share this one of the outermost electrons with the other atom, and this chlorine atom, it will share this electron with this other chlorine atom, and their shells will overlap, and electrons will be shared, and a bond will be formed, a covalent bond will be formed. So let me just pick this and bring it here. uh yeah, like this. Okay, so here you can see that now the shells are overlapping, the outer shells are overlapping, and in this overlapped area we can see a shared pair of electron, right? So this is the dot and cross diagram for Cl2. Now let us take a look at CH4. So carbon will be in the center, and we connect, or we draw hydrogen atoms on the sides. So carbon, it has 4 electrons in its outer shell, because it is in group 4, and it needs 4 more to have a complete outer shell, right? So these 4 electrons will be will be shared by these four hydrogen atoms, one each, right? So this hydrogen atom, let me just draw this shell. Yeah, and so each hydrogen atom, it will donate this electron or share its electron with carbon atom, and carbon in turn, it is also sharing these four electrons with each of each one with the hydrogen atom. So now here you can see that uh, yeah, so this is now a shared pair of electron here, and here this hydrogen is also sharing, and in turn carbon is also sharing its electron with this hydrogen. And now this hydrogen atom is, so now two electrons are being shared on this side, and like this, right? So this is how you draw the dot and cross diagram for methane. Now for ammonia, again, you can pause this video here, and you can draw for yourself the dot and cross diagram of ammonia. So nitrogen will be at the center, and nitrogen has five electrons, since it is in group 5 and period 2. So it will need three more electrons to have a complete outer shell. So out of five outer electrons, nitrogen will share its three electrons, right? Because it needs three. So one, two, three, and the remaining two electrons, I will draw as a pair on the other side, on this side here. Now let us attach hydrogen atoms. So the shells must overlap. So one hydrogen on this side with its own electron, mentioned as a cross, and now here a hydrogen atom with its electron across, and here another hydrogen atom with a cross, right? So this is how we draw a dot and cross diagram for ammonia. So you can draw HCl for yourself, and let me know in the comments below that how many electrons are shared between hydrogen and chlorine atoms in hydrogen chloride molecule. So this is how we draw dot and cross diagrams. And the next topic is describe in terms of structure and bonding the properties of simple molecular compounds. A, low melting points and boiling points. B, for electrical conductivity. So for simple molecular compounds, we need to understand what simple molecular compounds are. Simple molecular compounds are those compounds that can exist on their own. For example, carbon dioxide. So let's say if we have two carbon dioxide molecules, they can exist independently, and there will not be any covalent bond between them. So these are called simple molecular compounds. So those compounds in which between between the molecules there is no covalent bond, right? No covalent bond. These are called simple molecular. Again, water, for example, it is also a simple molecular compound, because between two H2O molecules there is no covalent bond, right? And on the contrary, we have giant covalent molecules. So it is important that I should talk about it here so that you can understand. So giant covalent molecules. So what will be the definition, or what will be the concept of giant covalent molecules? So giant covalent molecules, for example, diamond, each carbon atom is covalently bonded to four different carbon atoms, right? So and and silicon dioxide is another example, or silicon 4 oxide, SiO2. So each silicon dioxide molecule will be covalently bonded to another silicon dioxide molecule, right? So they form a network structure and they have very high melting and boiling points. But we will talk about this later. This is, I guess, related to extended syllabus. So, okay, now let's come back to the properties. So, yeah, so you just need to know that for simple molecular compounds, simple molecular compounds, we have they have low melting points, melting points, and they do not conduct electricity. They have a poor electrical conductivity, right? So why they have low melting points and why do they have poor electrical conductivity? This will be explained in extended syllabus. Students who are learning for the core syllabus, they don't have to worry about the explanation. So the reason is that since they are on their own, there is no attraction between one molecule and the other. That is why uh, they have a low melting and boiling points. We can say that they have like weak. There are weak intermolecular forces, right? And why they do not conduct electricity? The reason is because there are no delocalized electrons to conduct electricity, right? So or no free electrons to move, so they don't conduct electricity. Okay, so now we move on to the topic, the next one, which this is from extended syllabus, which says that describe the formation of covalent bonds in simple molecules, including alcohol. This is ethanol, CH3, OH. This is C2H4, O2. Yeah. So now let us draw the diagrams for these. So again, we start from carbon. It will be surrounded by three uh, hydrogens like this, and carbon is sharing, its four electrons with these three electrons out of four with these three hydrogens, and in turn, hydrogen atoms are also sharing their one electron with this carbon atom, right? Like this. Okay, and now oxygen. So I draw oxygen here like this, and well, let me just bring it a bit closer here. Yeah. So now this is the fourth electron of carbon atom. So this will be oxygen. Okay, so for oxygen atom, we have six electrons in the outer shell, and out of six, only two will be shared because oxygen needs two electrons to have a complete outer shell. So I will write, one electron here. It is sharing with carbon. Yes, and now the second electron, oxygen will be sharing with this other um, hydrogen atom, right? So like this. And for hydrogen atom, and this is the electron for of the hydrogen atom. Yeah, so now these are the two electrons that are shared by oxygen. Now the remaining four I will draw, or I will write here as pairs, right? Yeah, so this is the dot and cross diagram for alcohol, uh, this is methanol. So for this one, C2H4, so again, carbon and carbon. So this will be the structure. Remember that hydrogen atoms cannot be the central atoms. They can only make one bond. So these two carbon atoms will be connected directly. So again, I draw the, uh, let me just bring it here. Yeah. Yeah, so one, two, and 1 and 2. So now you can see here that we have two, we have four hydrogens. So two will be connected to each hydrogen atom, right? So one I connected here with its electron, and the other one I connect here. Okay, so the electrons of hydrogens are represented with a cross, and two I will connect here. Uh, yeah. So let me bring these electrons for of carbon atoms on the other side. Yeah, this one, and this is the electron from hydrogen, and this is the electron of carbon, and this is the electron of hydrogen. Okay, so now, uh, what do you think the octet of carbon, is it complete? One, two, three, four. For each carbon atom, we still this carbon atom needs four more electrons, because it is like we only have four in the outer shell, right? So the remaining electrons, two from each, they will be shared between these carbon atoms, right? So one, two, three, and four. So yeah, so now you can see that the octet of carbon for both the carbon atoms is complete, and this is the dot and cross diagram for C2H4. This one is a bit tricky as compared to the others in which all the bonds are single. So you must pay attention to the number of outer electrons, and each atom must have a full outer shell. So in case of hydrogens, we should have two, and in case of the others, like other than hydrogen atoms, there must be 8 electrons in their outer shells. So now let us draw for oxygen, O2. So again, we know that oxygen is in group 7, group 6. So it will have 6 electrons in the outer shell. It needs two more. So 2 electrons will be shared by each oxygen atom, and the total number of electrons shared between them will be 4. So let us draw, this is oxygen, one oxygen atom, and let us draw another oxygen atom here. And now let us draw the electrons. So 1, 2, 3, 4, and 5 and 6, and yeah. And now this the other oxygen atom with 6 electrons. I am representing these 6 electrons using dots. So 1, 2, 3, 4, and yeah, so 5 and 6. Yes, so you can see here that 2 electrons are being shared by this oxygen atom, and 2 by this oxygen atom, and 4 electrons are shared here, and that is the dot and cross diagram for O2. Remember that it's 2 electrons per bond, 2 electrons per bond, meaning that when a pair is shared or when 2 electrons are shared, so there will be a single bond, and when 4 electrons are shared, there will be a double bond, and when 6 electrons are shared between the two atoms, it means that there will be a triple bond in that molecule between the two atoms. So nitrogen in this case, what do you think that how many electrons will be shared between the two nitrogen atoms, and what will be the number of bonds in nitrogen molecule? So you can pause this lecture here and try to draw it yourself, and let's see what you get. Okay, so I am drawing it now. Uh, Here, nitrogen again. We draw the outer electrons, 5 electrons. Out of 5, 3 will be shared, right? Because it needs 3 more. So 1, 2, and then 3, 4, and 5. And for another a nitrogen atom, it will be the same: 1, 2, and 3, 4, and 5. So when now three electrons will be shared by this nitrogen atom, so that this nitrogen can have a complete outer shell, and 3 electrons will be shared by this nitrogen atom, so that this nitrogen A, can have a complete outer shell. So now let me draw it. So now the orbitals, the orbits, the shells will overlap, and you must neatly represent the sharing of these 6 electrons between these 2 atoms of nitrogen. And since 6 electrons are shared here, so it means that we have a triple bond between these nitrogen atoms. In a nitrogen molecule N2, there's a triple bond. Remember that, right? So it's a triple bond. Okay, and in oxygen molecule O2, since 4 electrons are shared, it means that there is a double bond between these 2 atoms in oxygen molecule. Okay, so now I hope this is clear. Now we move on to the final topic, which says that explain in terms of structure and bonding the properties of simple molecular compounds, low melting points and boiling points in terms of weak intermolecular forces. So I explained it above that what are simple molecular compounds? These are compounds that are not covalently bonded to one another. They are free, and they have a weak attraction, weak intermolecular forces, right? And that is why less energy is required to change their state, to melt or boil them. And similarly, poor electrical conductivity, because electrical conductivity arises when there are electrons present, which are delocalized, which are free to move, right? Which are not associated to any atoms. So we will see, we will study about this in more detail in metallic bonding, where the electrons, they become delocalized, and they start conducting electricity because they are free to move. They are not associated with any nucleus. So since here we don't have any such case, so that is why covalent compounds consisting of non-metals, they do not conduct electricity no matter what the state is, right? Remember that. No matter if they are in liquid state, solid, or gaseous state. Like we learned in ionic bonding, that ionic compounds can conduct electricity in a molten state. They don't conduct electricity in a solid state because the ions cannot move. But in a molten state or in aqueous solutions, when they are dissolved, so they can conduct electricity. The reason is that the ions can move. But in this case, we don't have any ions. In covalent bonding, there are no ions. So that is why this change of state doesn't affect the electrical conductivity. No matter what the state is, they will not conduct electricity, right? So there can be some exceptions. For example, graphite, where we have a delocalized electron, but I think that we will cover that in our next lesson. So this will be all for today. You can join my school community, where I offer once a month, one lesson a month for free. And if you wish to join my group lessons, there's a premium package available. The link is given in the description, where I offer 4 lessons a month. So and there are also discussion forums. You can ask questions there, like there are other students as well that you can interact with. So it's a very good place to be if you are learning chemistry, or if you're excited about chemistry. And I also offer one-on-one lessons, and the Google form is given in the description. Seats are very, very limited, and if you're interested, if you are preparing for November final exams, or like May June session, you can contact me as early as possible. so that, because I only take a specific number of students each year, so that you don't miss out. All right, then this will be all for today, and I'll see you in the next one. Take care. Goodbye.